Welcome back. Well, I'm now going to do some more examples, I guess a bit of a review of some of the derivatives that we've been seeing, and then I'll introduce you to something called the chain rule, which kind of expands the universe of the types of functions we can take the derivatives of. So in the last presentation, I showed you if I had a function like, let me see, if I had, say, f of x is equal to, I'm just going to make something up, 10x to the 7th plus 6x third plus, I don't know, 15x minus x to the 16th. To take the derivative of this entire function, we take just the derivatives of each of the pieces, right? Because you can add them up. So f prime of x in this example, f prime of x is equal to, and I think you get the hang of it at this point. It's actually fairly straightforward. We take the 7, multiply it by the 10, so we get 70x, and then 1 degree less, so 70x to the 6th, plus 18x squared, plus 15, right? We can kind of view this as x to the 1, right? So it's 1 times 15 times x to the 0, which is 1, so that's just 15, minus 16x to the 15th. And I don't want you to lose sight of what we're actually doing here. What is f prime of x? This is the function that tells us the slope of any point at, x along the curve f of x. So it's a pretty interesting thing. I mean, let me just draw, just to maybe give you a little bit of intuition. Let's say that this, I don't know what the slope of f of x really looks like. And actually, let's pretend like this isn't f of x. Let's pretend like this is just some arbitrary function I'm drawing. If this is f of x, just some curve that does all sorts of crazy things, the f prime of x tells me the slope at any point along that line. So if I wanted to know the point, the slope at, say, this point right here, I could use the derivative function to figure out the slope of the tangent line, which would be, the tangent line is something like that right there. Or if I wanted to figure out the slope at, say, this point, once again, I would use the derivative function, and it would tell me the slope of the tangent line at that point, which would be something like that. So it's a pretty useful thing, and once I give you all the tools to analytically solve a whole host of derivatives, then we'll actually do a bunch of word problems and applications of derivatives, and I think you'll see that it's a really, really, really useful concept. So let's move on. I think you get the idea of how to do these derivatives of polynomials. Let me erase this. I'm actually using a different tool now, so I think it might be a bit easier. But let's see, someone was calling me, but you're more important, so I will not answer the phone. So let me erase this, make sure I'm using the right tool. And now I'm going to introduce you. This tool doesn't have, I don't think it has just a straight up erase. Actually, maybe, let's see, if I do it like this, if I just do this, and then, let me see, nope. If I did, well, let me see. If I just, no, that doesn't work. Let me just erase like this, the old-fashioned way. Takes a little second. You just have to bear with me. And then once I finish erasing, I will show you the chain rule. This is good. It feels like I'm a real teacher with a real chalkboard and a real eraser now. Almost there. This is a lot cleaner than a normal chalkboard as well. Bear with me. Almost there. I'll figure out a faster way to do this over the next couple of videos. It's pretty sad. I'm showing you how to do derivatives in calculus, but I don't know how to erase a faster way than this. Just bear with me. There, we're done. Okay, so now I'm going to show you how to solve the derivatives of a slightly more complicated type of function. It's actually, it's not more complicated, it's just different. So let's say let's say f of x. Let's say f of x is equal to 2x plus 3 to the 5th power. And I want to figure out the derivative of this. We're going to use something called the chain rule. Because one thing we could do, we could just multiply out 2x plus 3 to the 5th power. And if you've ever done that, you know it's a pain. So that's not something we'd want to do. So we're going to use something called the chain rule. And I'm just going to give you a bunch of examples before I even show you the definition of the chain rule, because I think this is something that you just have to learn by example. So the chain rule just tells us that the derivative of, let's say, this function right here, it's just, you take the derivative of kind of the sub-functions, and then you could take a derivative of the entire function. I'll tell you kind of that formally, but I think when you introduce it formally, it gets more confusing. So what I do, I just take the derivative of 2x plus 3 first. And actually, let me use some colors, so I think that might simplify it. So I take the derivative of 2x plus 3. What's the derivative of 2x plus 3? Well, you know that. It's just, the derivative of 2x, which is 2. And then the derivative of 3 is 0. So the derivative of 2x plus 3 is just 2. And then I'm going to multiply that times the derivative of the whole thing, and I just pretend like 2x plus 3 is just like a variable by itself. So then, what's the derivative of x to the fifth? Well, the derivative of x to the fifth, I'm going to do that in a different color. So the derivative of x to the fifth, is 5x to the fourth, right? So it'll be 5 times something to the fourth. But here we didn't take the derivative of x to the fifth. We took the derivative of 2x plus 3 to the fifth. So we just put the 2x plus 3 there instead. 2x plus 3. So what did we do here? We went in kind of the inside of the function, and we took the derivative here. The derivative of 2x plus 3 was this 2. And then we multiplied it by the derivative of kind of the greater function, and we just pretended like the 2x plus 3 was a variable. It was like x. So we got 5, instead of 5x to the fourth, we got 5 times 2x plus 3 to the fourth. And if we just simplify that, f prime of x is equal to 2 times 5 is 10. 10 times 2x plus 3 to the fourth. That was a lot simpler than multiplying out 2x plus 3 to the fifth power and then doing the derivatives the old way. I know this was probably a little confusing to you, so I'm going to try to do a couple of more examples. Let's say I had, let's change it a little bit. G of x is equal to, let's say g of x is equal to x squared plus 2x plus 3 to the 8th power. So g prime of x is going to equal, well, what did we say? We take the derivative of the inside. This is called the chain. We take the derivative of the inside. What's the derivative of the inside? It's 2x plus 2 plus 0, right? Take the derivative of the inside. And then we take the derivative of the whole thing, and we just pretend like this whole expression, x squared plus 2x plus 3, is just kind of like the variable x. So if it was just, we know that the derivative of x to the 8th is 8x to the 7th, right? So it'll be 8 times something to the 7th. And that something is this entire expression here. 8 times x squared plus 2x plus 3. I hope I didn't confuse you too much, and you could simplify this more in any way, because it's 2x plus 2 times 8 times x squared plus 2x plus 3 to the 7th. To multiply this out or to multiply this out is a huge pain, as you know. But we could simplify a little bit. We could just say, let me draw a divider here. We could say that that equals, let's see, 8 times 2x, 16x plus 16 times, I'm making it really messy, x squared plus 2x plus 3 to the 7th power. Hope I didn't confuse you too much. In the next presentation, I'm just going to do a ton of examples using the chain rule. And I think the more examples you see, it's going to hit the point home. And then after I've done a bunch of examples, then I'm going to give you the formal definition. I think that's actually an easier way to digest the chain rule than giving you the formal definition first and then showing you a bunch of examples. So I'll see you in the next presentation.